for the last part of this class, we are going to look at on this construction noise prediction, okay, for our final class today, for our final meeting, right? Okay, so far, as for now, I hope all of you can relate the previous fundamental, previous principle with the calculation. And as a reminder for your information, this topic will be included in your final exam. So there will be calculation part for my topic, for my parts actually, for construction noise management. So I hope that all of you can understand this very well, understand the calculation, the flows of the calculation on how the steps to come out with the noise prediction, so that I really hope that all of you can score this part, okay? Because for the final exam, my part contributes for 40 marks, okay? And the rest of the two parts previously by Associate Professor Dr. Rozana and Dr. Fairuzan contributes for 30 marks each. Okay, so the total are going 100 marks. It will be 100 marks. Okay, so as for our final quick chat, okay, so far we have covered these three main topics: construction noise issues and management as the fundamental or overview parts for this topic. And we proceed with the noise propagation. And just now we have covered on noise monitoring, measurement, and abatement, right? And then the last one we are going to cover on this one, construction noise prediction. Okay. Again, for the assessment, I will upload it after the class, right? So it's gonna be group assignment. Okay. So for your information, the group members stick to the same one, okay, as assigned by Dr. Fairuzan. So I think it is easier to stick like that, right? To just follow the same grouping for the purpose of this assignment also, right? Okay. These are several outlines or several subtopics related to the calculation. We are going to look at on the overview of noise prediction. And then for the noise prediction, we are going to use LAEQ method. It's an established method by British Standard BS 5228. Okay, and then we are going to go through the calculation of noise level pollution, which include the pro forma methods to calculate the noise prediction. And also at the end, we are going to look at on the annoyance response evaluation, right? Okay, the next one. Okay, for the overview of noise prediction, it actually an important element in controlling construction noise pollution. And this noise prediction must be carried out in effective noise management. So that's just for the overview for the how we on why actually we need this noise prediction. Okay, and I have also mentioned previously. Okay, so this noise prediction can be carried out at the planning stage. Okay, as we discussed just now, and during the construction process as part of the noise monitoring. So it can be conducted in both stages, at the earlier stage and during the construction stage. And the main purpose or the main function of noise prediction is that we want to avoid the public, okay, the community from being exposed to the high noise level, the excessive noise exposure level. So that's why we need to predict it first. We need to forecast. We need to foresee the situation so that at the later part, okay, especially during the construction progress, we try to minimize or try to avoid all the potential impacts to the nearby community, especially in regards for the noise exposure. Alright. Anticipated annoyance could be predicted, as I mentioned, as we discussed just now. Anticipated annoyance could be predicted, and any appropriate mitigation can be proposed. Okay, so this one is very necessary because the developer or the contractor need to submit this for the EIA, Environmental Impact Assessment, at the planning stage to the Department of Environment, so that they have included this all of the information related to the construction noise measurement. So in that report, they have included the impact of noise to the nearby community. That's why, according to the EIA report, apart from the air pollution, okay, apart from other environmental pollution, the noise pollution itself become a mandatory component. Okay, so that's why it's being included and it's being predicted at the earliest stage. All right, and then as I mentioned, construction noise prediction method by using PS5228 method is the most recommended approach so far. Okay, so that's why we are going to use LAEQ method, okay, as recommended by the standard. Okay. This method can be used by the EIA consultant, which represent the developer in predicting noise prior to construction of a project. So that's how that's actually the method that we are going to use, and it offers the most accurate prediction, provided that the input was obtained by carrying out noise measurement of a similar construction plant and equipment. As long as we have the input from the correct or appropriate information, okay, we have similar data from the construction plant and machineries, the same operation mode, and also the power of the individual machineries. So hopefully we can come up with the accurate prediction. Okay? That's the requirements. So for example, if we want to use excavator in our upcoming project, so in terms of the prediction, for the purpose of prediction, we need to obtain the similar data which can be referred to the established database related to the excavator, so that the input itself will be the correct one, okay, for the prediction. That's the meaning of this statement. Okay, this is the method that we are going to use, LAEQ method. It's actually a simple construction noise prediction which recommended for the developers, architects, engineers, and other parties which are responsible or related to the project. Okay, anyone who responsible to come out with the prediction. Okay, so by using or by applying this method LAEQ, it requires sound level data, okay, of the equipment with an AQ of 10 meter as suggested in BS 5228 Part 1 2009. Right. So I think this one, the related guidelines, the related additional reference, I have uploaded in the e-learning. So you may refer to the system, to the e-learning for all the notes, for all the additional reference together with the lecture recording. Okay, you can try to briefly look at on this standard. Okay. Besides sound level data, for example, we have sound level data for excavator, okay, a dump truck, and also other equipment. It also requires data concerning the machine operation, periods operation. So we need to know, we need to plan the machine operation periods. Okay, any available screening or barriers exist on the site, or any reflection surface. Okay, so this one will be related to our calculation. Okay, we need to consider all of these factors to be included in our prediction. So later on, I will explain again on these factors, okay, which may affect the prediction value or the calculation value. All right. So what we are going to calculate is that we want to know the LEQ. Again, LEQ refers to the equivalent continuous SPL or some pressure level with A weighted. Okay, A weighting. Okay, so what we are going to do is that we need to have the information or the data of the individual sound power, okay, which can be extracted from the existing sound level databases. As I show just now, okay, we have comprehensive databases from the British Standard part. Okay, we may extract the information from the what we call from the database, or we can also do the actual measurement for the individual similar construction machineries. Okay, so this value will be deducted. Okay, we need to include or impose the correction value here. Okay, for your information, for the calculation, we have these four correction factors. The first one we have KD, which refers to the distance correction. And then the second one we have SKS for screening. Third one, KR for reflection, and KT, the fourth one or the last one, to represent the correction for percentage on time. Okay, so each of these will be included in your calculation. We need to consider all of these correction if they are exist at the construction site, in the construction site. All right. So by using or by applying this LAQ method, there are several factors may influence the predicted noise level. As I mentioned just now, we have several correction value, KD, okay, we have KS, KR, reflection, and also KT, percentage on time correction. Okay, based on this figure, we can see that the visualization between sources of noise we have here, the source probably in the construction site. So we assume this is from construction site. Okay, so the sources of the noise generation are from these two equipment or plant and machineries, such as lorry. We have lorry here, and also we have excavator. Okay, basically this one for earthwork. Okay, the excavator may excavating the works and also load the soil to the dump truck or lorry to transfer to the dump site. Okay, so that's the source of this example or this figure, the source of noise. And on our right side, we have the receiver point, okay, meaning that the nearby residents or any community. Okay, for example, here we have residential area, we have the receiver or the residents can live adjacent to the construction site. Okay, so he or she will be the or might be the affected receiver for this construction noise. Okay, so this is the receiver point, and this is the source point, source of noise level. Okay, noise exposure. Okay, so KD refers to the distance between these 2 points, source and also receiver. So this is how actually this KD refers to. So we need to remember this one. KD refers to the distance between the sources and receiver. Okay, so that it is easier for you to do the calculation later on. Okay, and then that's for the first fraction or the first factor. And then we have here barrier. Okay, if you look at to this figure, we have this the soil which is become a barrier here, the damp soil here, it become a barrier between this transmission path. Okay, if we look at back the concept of source, path and receiver, source path receiver concept, we have this path or transmission path of the noise. So this what we call the existence of this soil dump become the barrier between these two points. Okay, so that's why by having this barrier, the existence of this barrier, should we should consider the KS, okay, for the screening, meaning that there is existence of barrier or existence of screening between these 2 points. That's for the second factor. For the third factor, we have KR, reflecting surface. Okay, if we notice that if the receiver, okay, here for the monitoring purpose, we will set up the sound level meter using the tripod at the same point here. So if this receiver point closely located to this nearby surface, okay, especially the structural surface or any hard surface that can be reflecting surface, so we need to impose correction for reflection. Okay, for example, we have wall, we have any reflecting surface, we need to impose this KR. Okay, for the KT, percentage on time is referring to the percentage of the individual machinery in working mode or in operation mode. Okay, how many percent for example, the lorry or the excavator in its operation mode. For example, out of 8 hours or 12 hours working hours, it is being operated for example, 6% and 6 hours out of 12. So the KT will be 50%, half of the total working hours. So that's actually what KT refers to. Okay, so that this one, all of this we are going to relate with the calculation. Okay, now we are going to look at on the process or procedure, the flows for the calculation. Okay, so far is everything good before I proceed with the calculation? Can all of you understand this? Okay, for those who have what we call the construction noise issues measurement and prediction books, you also may refer to the books. Okay, basically my slides is the simplified version based on the books. Okay, you may refer both either based on the books and also to the lecture notes, as long as you are able to understand the contents, the flows to do the calculation, right? So throughout your revision, throughout your study period, if you have anything to ask, okay, you may ask me, because the final exam is just around the corner. Okay, as I'm being informed, the final exam will be on 5th of February, right? Okay, Saturday. Okay, so I hope that all of you have can allocate your time so that you can do all the required revision. Okay. All right. So for the calculation part, which is focusing on the construction noise prediction. Okay. On our left side, we have this flow chart. Okay, representing the steps to be followed in predicting the noise level, in calculating the noise level, right? So what we have here is that from the start or the first point, we need to have the information of individual LEEQ at 10 meter. Okay, It's either based on the database or measurement. As I mentioned just now, we can extract the related information for the individual missionaries based on the database established by the standard, or we can do similar, we can do the measurement of similar individual missionaries or construction plant related to our activities. Okay, so that's how we extract information. Okay, for the purpose of assignment, for the purpose of final exam, all of these, what we call all of these values, all of these LAQ for each machineries are already given. So you just straightforward refer to the given information, right? Okay, so another thing related to this one, okay, you need again to remember and differentiate between LW and versus LP. Okay, so you need to have remember this. Okay, LW refers to the sound power level of each individual machinery, and LP is the sound pressure level. So we need to use this sound pressure level to proceed with the calculation. So try to look at again the lecture notes on how we convert this LW to LP, right? You need to differentiate whether it is the equipment itself is radiated in spherical or hemispherical radiation. Okay, you need to know this one. Okay, once we have the information, we need to do the correction. Okay, as I mentioned just now, we need to proceed with the KD. Okay, for this correction, we need to proceed with the KS, screening, reflection, and KT for the percentage of time. Okay. For the KD, okay, for information, we have two types of correction here, two types of what we call the condition, okay, for the distance correction relating to the type of soil here. Okay, so if the construction site itself or the condition that related to our proposed location is categorized as soft soil, so we are going to use this one, the first question. And if it considered or categorized as hard soil, we are going to apply this formula, KDH, okay? Distance correction with soft soil, and this one for hard soil. Okay, the only difference that we have is at the end, we have this constant value to be applied. Okay, so again, for the purpose of assignment or for the purpose of final exam, if the information is given, straightforward given to you, you just apply, you just follow the given information. However, if it is not available, so you may use your own assumption. You can either assume the site is soft soil or hard soil. Okay. All right. So that's for the distance correction. This one. Step. Okay. This one. Next one for the screening correction. Again, for the screening, also we have two types of correction that we need to impose or apply to the calculation. It can be either half or partial, okay, and full screening. So half or partial screening is usually refers to, just now we have barrier from the dump soil, okay, dump soil, or any other screening which is what we call halfly or partially cover the transmission path. Okay, if the screen is fully cover the transmission path, we need to impose this value, -10, right? So the example for full screening is hoarding, okay? Because the hoarding itself or noise barrier already cut the transmission between the receiver and the noise source, right? So I hope you can differentiate this screening correction so that you may apply in your in both of your assignment and also in your final exam question, right? And then the next correction again, reflection. We have KR here. Okay, the next one is KR. KR, if there is any reflection surface, okay, closely or nearby to the receiver point, you need to add 3 decibel. Okay, for example, just now, based on the previous figure, we have this structure or either the house or the school, any other premises. If the receiver point is closely positioned to this nearest reflection or any structural surface, so you need to consider this reflection correction. So it's usually within 1 meter. If it is in 1 meter distance between this receiver and the nearest structural surface, so you need to impose this correction value. Okay. And then the next or the last correction that we need to consider is that percentage on time. Okay, percentage on time. How we calculate this? What we call this KT is, for example, just now, it is given that the total working period, okay, let's say it's 12 hours maximum, and the time for the individual machineries, a lorry or dump truck or excavator, is only 6 hours out of total working period. So you do the simple division and times with the 100, and at the end you come out with the percentage of the working period, which is 50%. Right. So this mean this 50%, this value you need to refer to the table. So later on I will share the related table that you need to refer. And at the end, once you have done all of this step, and then you need to add, you need to subtract the value in all steps, and you need to calculate the combined LQ. Okay. For your information, do not really worry, because the related formula, the related tables or charts will be given in your assignment and also in your final exam. Okay, as long as you understand, you can differentiate or identify which formula to be used, then it's okay. Okay, you can proceed with the calculation. All right, sorry. For the combined LAQ, you need to use the log formula. Previously, I have already explained that sound itself, in terms of calculation, we need to use logarithmic formula instead of arithmetical. Okay, that's the nature on how we want to calculate the sound. Okay, this is the table for KT, percentage on time correction. Okay, for example, just now, after this, we are going to look at on the simple sample question. Okay. As for now, we just take it this value 50%. Okay, 50%, we refer back to this table. This one is 10%. So this one 20, 30, 40, and 50. Okay. So if we look at the reading, so 50 should be around plus minus this one. Around this one. Okay. About 3 decibel. Okay, you can take this value 3 decibel and include it in the calculation, right? Okay, that's for the KT. And this is the same, what we call the same tables as I mentioned or presented previously, related to the characteristic features of the sound. Okay, if for example, if we are calculate or predicting the noise from the piling works, okay, for sure the piling machine. So we need to include this speed factor for the impulsive noise. Okay, this one will be included in the calculation also. Okay, for the sound level rating, okay, LR. Okay, for the spectrum character, audible tone, audible tone mostly from the lorry, okay, from the excavator. So any present of wine, so we need to have this correction value. Similar goes for the percentage of time. Okay. All right. And this one for the evaluation of the noise impact and also the anticipated community response, which is the same as previously. Okay, we have this category or we have this several values which represent the impact and also the anticipated distribution for the community response, right? I hope all of you can relate all of these. Okay. So before we proceed with the sample question, do you have anything to ask? Is everything good? So far, can you understand this, all of this? Okay, right. So I really hope that all of you can understand all of these, what we call topics, subtopics, okay, related to construction noise measurement. Okay. So later on, for the purpose of revision, for the purpose to study all of these subtopic, all of these content, you can later I will share the assignment for question for the group assignment. So that one, that assignment will be part of your revision as preparation for final exam. Okay. Okay, back again to this sample question. It is mentioned that there is site clearance or site clearing activities for demolition of old building. So basically, this is the site clearance or clearance of site activities being conducted, and the site is in between two existing buildings. So we can see that there is nearby premises, okay, that we need to consider, and there is an entrance to one of the buildings. So later on, I will share this what we call this figure, and it is given that the measured ambient sound level. Okay, again, this is the background noise level or background sound level represented by L90 without any activities is 58 with 15 hours working period. This is the several given information, and it is assumed that this activities site clearance involve backhoe, okay, backhoe and excavator, right? All of these also have been summarized in the table. So later on, I will share also the summary of these statements or the questions. Okay, for your information, this what we call the view or the form of the question. It can either be in the form of table form, which is summarize all of the information, or it also can be in combination of table form and also given figure. Okay, so you need to properly extract information from the given figures or the table. Okay. And for this sample for this sample question, it mentioned that backhoe with 90 kilowatt, okay, some power level to clear the site, okay, by loading rubble into a waiting 10 ton lorry. Okay, this is the description of each of the individual plant involved in the construction site. Okay. So, the other statement related to the working mode of the backhoe. And the last one related to the excavator. Okay, what type of activity that this excavator conducted? Okay, for example, digging the rubble and bring the rubble near to the backbone. Okay, okay. That's the previously the information or description for the sample question, and this is the given site layout. Okay, based on this one, as I mentioned just now, it can be the combination of figures and also tables, or sometimes it's only the tables. As long as you have the sufficient information to proceed with the prediction. Okay, so this is the setting. Okay, the what we call the layout for this specific site. Okay, we have here we have the receiver point. Okay, which close to the high building, and we can see the existence of rubble between receiver and excavator. This excavator will be the source one. So we will be the noise source 2, and then this is the third source, right? So each of these one have its own, we call its own distance. Here we can see that distance from receiver to the excavator is 110 in meter, and all of this will be necessary in your calculation. All of this information. Okay. Okay, this is the table that I mentioned just now. It's either summarized in this table, or you just extract from this one. Okay, this 100, 80, and 110. Okay, it's already summarized here, the distance. And some pressure level at 10 meter. Okay, this one. It's not being highlighted in this side layout, however, it's given in the table. Okay, for this sample question, we have these three machineries: excavator, backhoe, and lorry, with its own some pressure level. Okay, if you look at here, we already have some pressure level here, which represented by LP. Okay, if the given information in LW, some power level, okay, you need to convert first LW to LP. Okay. Okay, there are formulas to convert this accordingly. Okay, we have the spherical and hemispherical radiation. Okay, okay, you need to remember that spherical radiation formula is for any noise sources hanging, okay, in the air, and this one on the ground. Okay, if we relate to the construction plant and machineries, most of the time the spherical radiation will be applied for piling works, okay, piling machine. Okay, the rest of the equipment will apply this formula, hemispherical. Okay, since it is positioned or located on the ground, meaning that the source of noise itself generated or radiated above on the ground level. Okay, and the other information, this one distance, and then we have duration of working in hours. Okay, this one will be related lateral to the KP, okay, percentage of on time correction, and we have here screening. Okay, screening information to be included in the calculation for KS correction. Okay, so that's why I had already mentioned that this table has straightforward summarize all of this information. Okay, you can see here that excavator have screening due to this one rubber. Okay, if it's not mentioned like this, you need to do your own evaluation and need to identify which what we call which equipment as its screening, either half or full screening. Okay. And the other information given for this sample question, there will be no holding at the boundary. So if there is no holding, meaning that we don't have any What? Any of you can describe this? I have explained this one just now. Okay, it's related to the screening. Any of you can describe this? Nobody? Okay. What's the meaning of no holding at the boundary? How it affect the calculation?
Holding will basically like hold the sound from like going outside of the site.
All right. So meaning that,
Area.
okay, so there will be no, what we call, no screening between the receiver and the source. So if we relate to our calculation, there will be no, what we call, screening correction to be imposed, right? For the rest of the equipment, backhoe and lorry. Okay. If we can see here that only rubber here cause the half or partial screen. The rest we don't have, meaning that from the receiver to the lorry, from receiver to the backhoe, there are no existence of holding, okay, in between. Okay, that's the, what we call, that's the situation, right? So that all of you can have a clear view and can imagine what's actually this screening refers to. Okay. The next one. The next one, okay, we are going to look at on the sample answer. Based on the given information, based on the tables and figures, we are translating or we are putting all the related information in this table. So for the purpose of both assignment and final exam, again, this is how you present your calculation. Okay, this is the suggested way for you to present the calculation in table form so that we can have a clear flow and also a clear what we call view for the calculation so that we can compile every individual calculation for the plant and machineries in one table, right? Okay, so we start with the list all the related equipment here. Okay, for this case, we have 3 equipment or plant and machineries, excavator, backhoe, and lorry. Okay, refer back to this one. And you need to put the value for the sound pressure level LEQ at 10 meter for each of these equipment. Okay. Just extract from the table, or for the certain case, you need to extract from the figure. And then we have distance correction here. This one, you need to do the calculation, okay, using the formula that I have shared just now for this one. If it is soft soil, you need to apply this formula. If it is hard soil, you need to apply with this minus for the constant value, -2. All right. So you try to do the calculation again, referring to this table, okay, and try to recheck all of these, okay. This one, I'm not remember whether this one is soft or hard soil. You may do the calculation. Okay, try to recheck again, and after that, impose for the screening correction KS. Excavator, it's already mentioned that it is half screening due to the rubber existence, and then you should -5 here. Okay. If it is a full screening, then you need to -10. And in contrast, for the backhoe and lorry, since there are no screening, so the value is 0. Okay. And proceed with the KR reflection correction. Since the receiver, it is mentioned that receiver or microphone is placed 1 meter from the facade of the building or the building structure. So that's why we need to put this correction value, right? And percentage on time. Okay, let's say for example, we take it excavator. Excavator is 6, right? Sorry, 6 out of I think out of 15. So 6 over 15. 6 over 15 times by 100. Okay, what's the percentage supposed to be? So this percentage you need to refer to the previous table and previous figure or chart. Okay, you need to check the correction value and include it in the calculation. Once you come out with all this one, and at the end you can, once you do the addition, you do the reduction or subtraction, and you can come out with this. Okay, each of these LAEQ for all the related equipment or plant and machineries involved for the certain construction activities. Okay, so for the individual value, we have 54, 69, and 56, and this is the split one or the individual one, and you need to combine. Okay, you need to combine the LAQ for the 15 hours working duration. So again, this one you need to apply the formula. Okay, I have shared the formula for on how you want to combine the value. Okay, you can refer to that and try to do the calculation by your own. Okay, as part of your revision and as part of preparing for the final exam and for the also for the assignment, right? Okay, so this upper part represent the calculation, and actually the bottom part is the recalculation after the mitigation. This one just what we call just the example, okay, the extension from this calculation. Okay, for example, if the question asks you to replace, okay, for this what we call, for just as for now, there is no condition or there is no requirement for you to do so. However, if you have any additional requirements, okay, for example, you need to do the mitigation, you try to replace backhoe and lorry with the lower some pressure level, okay, 87, 76 replaced with this one. Oh, sorry, only for the backhoe. 87 you replace with this data 76. So if there are adjustment here, okay, if there are new value here, then you need to recalculate again. So at the end, you will come out with another set of values, and you can recalculate for the combined LEQ. So we notice here that if we replace the individual equipment with lower sample level or some pressure level, at the end we can have a lower combined LEQ, right? So that's the example lah. That's the situation. Okay. I think that's all for the calculation. Once you have come out with this combined LEQ based on this table, so the next step is that you need to apply this value. For example, based on the sample question, the combined LEQ is 69, right? So this 69, you need to calculate for the impact and anticipated community response. Just now I have shown with you LR and also percentage of LR. Okay, you need to apply this formula to calculate the impact and also anticipated community response. Right, so here we have this one with the value from the what we have calculated just now. So the combined predicted LAQ is 69, and you need to what we call include the background background noise level or ambient noise level, or sometimes we also refer it as existing sound level at certain location. Okay, so this one refer back to the equation. It's already mentioned here. The measured ambient sound level without any activities is 58. So that's why this value we are included in this table for the calculation. Okay, so again, as a reminder, if there is no background noise level mentioned either in your assignment or in your final exam, for the purpose of calculation, you may assume the what we call the level is around 45 or 50 to 50. Okay, so sometimes we just use 50 or just use 40 for the simplicity of the calculation. Okay, so I hope that all of you can remember that. And then correction due to impact of one. Okay, this one back again, refer to the previous table. This one, if there is we call characteristic or the activities due to the piling, then we need to put this correction value to the calculation. That's why we impose these values here. Audible tone, right? Or one which is above 5 decibel, and calculate the LR. Okay, the calculated LR 74. Okay, so 74 would be minus this one 69 plus 5, come out with 74. 74 minus 58, we will have this percentage of sound level rating. And this value, take it and refer to the table. Okay, either which category in terms of the impact and community action. Okay, so 16 is already exceed 15 range, so it's very it can be refer back this one 16 here it can be in the range of strong to very strong. So this is the anticipated community response. Okay, vigorous. Okay, this is the calculation for the LR sound level rating. Okay, the impact. Okay, the anticipated community response, and okay, this is after mitigation by replacing backhoe. Okay. With that, I think that's all for the whole calculation. So I hope that all of you can understand this. Okay, try to go through each of the content. Okay, try to practice. Okay, try to do your own calculation, and if you have anything, you can ask me. Right? Okay. So far, is everything okay? Is everything good? Right? Okay, so hopefully all of you are able to understand all of this one, all of this topic. Okay, with this, I think that's all for my part. Okay, for my topics covering on construction noise management. Okay, again, just a recall, we have covered 4 main topics starting from the introduction, issues, okay, related to the construction noise management, up until this one, calculation of noise level prediction. So hopefully all of you can understand all of the components. Okay, try to relate the fundamental or the principle with the calculation that's related to the actual application. Okay, meaning that the actual situation. Okay, with that, I think that's all for today. I wish you all the best. Before that, please scan your attendance. for today's class, for final class.